So lesson 6 is on synthesis and decomposition reactions. Essentially, if you see a reaction that doesn't look like any of the other choices, so single replacement, double replacement, or combustion, you're going to have a synthesis or decomposition reaction. In order to differentiate between the two, decomposition will only have one reactant, synthesis will have more than one. We're going to work on predicting some products for some of these reactions, and we're going to talk about some examples here. So if we look at this first one, this one only has one reactant, so this is going to be a decomposition problem. So we have a mercury and an oxygen compound. If you see something that's made up of two elements, they're just going to break apart into their elements. So we have mercury and oxygen. But remember that oxygen is a diatomic, so it's going to break down to look like this, O2. Now we're going to have to work on balancing these, because if you check, we have one mercury, one oxygen, and two oxygens. This is going to be a problem. So if we put a 2 here, now we have 2 oxygens on both sides. So we're going to need a 2 here and have 2 mercuries on both sides. The next one, potassium chloride, is pretty much the same thing. That's going to break down into potassium. So potassium, let me leave it alone. Okay, so we're just going to write it out as an element, not an ion. And then Cl2, because that is a diatomic as well. So we just have to balance this in again. So we need 2 here and then a 2 here. Now, the next one, lithium and oxygen are combined to form a lithium oxide. So lithium oxide is LiO, since LiO, we have to figure out if it balances out. So -2 charge plus 1 charge. So that means this is going to be Li2O. So these are the reactants I gave you. This is what the product is. You kind of have to work on crisscrossing here. So now we have 2 lithiums, so we need a 2 over here. But then we have 2 oxygens, so I'm going to need a 2 here, which means that I need to make this a 4. So as we discussed with balancing, a lot of times it's some guess and check until you get to where you need to be. The next one is more straightforward. Carbon and oxygen are going to combine to form carbon dioxide. If you check, that one's already balanced, so we're good to go. K2CO3, that's going to break down into a potassium oxide and carbon dioxide. So we're going to have K2O, since there's a +1 charge, -2 charge, and then CO2, which that then is good to go. That balances out. Then we're going to talk about lesson 7, which is on combustion reactions. The products of these reactions are always carbon dioxide and water, but the trickiest task with these is to balance these. So these are more complex to balance and sometimes take a little bit more effort to get there. So if we look at this first one, for example, we have C6H6 plus O2. That's going to yield CO2 and water. Those are always your products. So the first thing, I recommend balancing carbons first and oxygen and hydrogen last. I just think that's an easier approach. So if I look, I have 6 here. So I'm thinking, okay, maybe I want 6 carbons there. Now I'm going to check this out. So I have 6 hydrogens here, only 2 here. So I'm going to try to put a 3 there. So now I have 6 hydrogens. But now I only have 3 oxygens. So that's going to make an odd number of oxygens, which I can't get from here. So then I'm going to say, okay, well then maybe this needs to be doubled so it's even, which means that I need to double this, which means that I need to double this. Okay, so now I have 12 carbons, 12 hydrogens, now I have 24 oxygens plus 6 oxygens, means I'm going to have 30 oxygens, which means I need a 15 here. So as you can see, these numbers out in front get a lot higher for combustion reactions than any of the other reactions. Now, the next one's going to be definitely a challenge problem. We're going to work on the third one together, and I recommend you try the next 2. So if we have CH4, that's going to react with O2. That's going to form CO2 and water. So, first thing, I would check your carbons. The carbons are good. Hydrogens, I need a 2 here. Now I have 2 oxygens plus 2 oxygens, which means I need a 2 there. Okay? So the homework for tonight is the problems under lessons 6 and 7. So go ahead and give those a try. Let me know if you have any questions.